Sketch the output waveform as the capacitor C1 varies from very large values to very small values. This figure corresponds to a half wave rectifier with a capacitive type of filter at the output to reduce the ripple content. This capacitor is called as the smoothing capacitor. If this capacitor is absent, then the output waveform would look like this. So it will charge till the peak point of the input voltage, and whenever the input starts falling, so the output also starts falling. So if you see, this would be the approximate graph. So there is a large change in the output voltage from Vp minus Vd on to 0. So to eliminate these ripples, so this is basically called as pulsating DC. To eliminate these ripples, we use a capacitor. If we don't have this resistance RL, that is, load is not connected, we have only a capacitor, then the waveform would look like this. After the first quarter of the cycle, the capacitor would retain its charge, because at this point the diode will be off, open circuit, and there is no path for the capacitor to discharge. So the voltage across the capacitor will remain constant like this. This is an ideal scenario, but in coming to the practical scenario, there is a load and the load draws some current. So whenever there is a capacitor, the capacitor will try to discharge through the load. We cannot stop this discharge, but we can control this discharge rate, the speed at which it is discharging, by choosing C1 value. RL is the load resistance which is not in our hands. It depends on the load we are going to connect, say your charger or your cell phone or anything. But C1 is a circuit design parameter and it is in our hands. So this half wave rectifier circuit with a capacitive smoothing filter, output waveform will be like this. By choosing C1 value, we can control this discharging slope, this discharging rate. So from 0 to T1, this is the circuit where the diode is on, replaced by VD on or V gamma voltage source. So the capacitor will be charged till the peak value of the input signal. After T is equal to T1, say T equal to T1 plus, now the diode acts as off, open circuit. So only capacitor and load resistor will be there. So the capacitor tries to discharge through this resistance following this path. If C1 is very large, the discharging time constant C1 into RL will be very large. That is, it takes very large time for this capacitor to discharge to the load. It discharges slow. When D1 is off, the current drawn by RL will be very less when C1 is very large. So you can see here, it has a gradual slow roll off, slow slope, large C1. But if you decrease the value of C1, it starts to fall quickly, high slope, little high slope. If C1 is very very small, then the capacitor C1 very quickly discharges through resistance RL. That is, you can see the slope here. For very small C1, discharging time constant C1 into RL is very less. So within no time, within very small time, the capacitor is discharged, and hence again you are getting huge ripples.